This video, we will be discussing about Mathematics Paper 4, Mechanics, 2024, May-June, variant is 43 and the subject code is 9709. And in the description and in the comment section, you can get the solved PDF link, and also there is a video that how to download the solved PDF, and also the timestamps for this video is provided in the description. Question number 1. Two particles P and Q of mass 0.2 kg and 0.5 kg respectively are at rest on a smooth horizontal plane. So P and Q of mass 0.2 kg and 0.5 kg are at rest. P is projected with a speed of 6 meter per second directly towards Q. So P is projected with a speed of 6 meter per second towards Q, and Q is at rest. After P and Q collide, P moves with a speed of 1 meter per second. So after P and Q collide, P moves with a speed of 1 meter per second. Find the two possible speed of Q after collision. So we need to find the two possible speed of Q after collision. Now, here we have given the values for speed. So these values are speed and not the velocity. So this is the initial condition, and after the collision, let's consider the speed of Q as v. So here we can see that the speed of Q is v in both the situations, but since we have given the speed of P, that is 1 meter per second, so speed has no direction. That means P has a speed of 1 meter per second towards this direction, and also P has a speed of 1 meter per second towards this direction. And so if we consider the right as positive, then 6 meter per second is positive and 1 meter per second is positive, but moving towards left is negative. So since for this condition, when P is moving towards left with a speed of 1 meter per second, we consider since it is moving towards left, so the speed is negative, that means the velocity is negative. So here we are considering the velocity. So when P is moving towards right, what is the value of V for Q? So by using change in momentum, that is initial momentum is equal to final momentum. So mass into velocity of P plus mass into velocity of Q, and the velocity of Q is 0, is equal to after collision, that is mass into velocity of P. So let's consider P is moving towards right. So mass into velocity of P plus mass into velocity of Q, and here V is the velocity of Q. So V comes to be 2 meter per second when P is moving towards right, and when P is moving towards left, so since it is moving towards left, so the velocity would be negative. So initially, that is mass into velocity of P plus mass into velocity of Q, that is mass into velocity of Q, is equal to mass into velocity of P. And now P is moving towards left, so the velocity would be negative. Since velocity is a vector, so it has both magnitude and direction. And since it is moving towards the negative direction, so the velocity is negative. Plus mass into velocity of Q, where mass is 0.5 and the velocity is v. So after calculating, we get the value of v as 2.8 meter per second. That is, when P is moving towards left, the speed of Q is 2.8 meter per second. So here we get the two speed of Q, that is 2 and 2.8 meter per second for the speed of Q after collision. Number 2. A particle of mass 0.2 kg is attached to one end of a light inextensible string. So particle of mass 0.2 kg is attached to the string. The other end of the string is attached to a fixed point on a vertical wall. So the other end is attached to on a vertical wall. The particle is held in equilibrium by a force of magnitude x. So the particle is held at equilibrium by a force of magnitude x, and the particle is in equilibrium. That means the resultant force is 0. So x perpendicular to the string. So x perpendicular to the string, here we can see that x is perpendicular to the string, with the string taut making an angle of 30 degree with the wall. So the string is making the angle of 30 degree with the wall. Find the tension in the string and the value of x. So we need to find the tension in the string and the value of x. So for the string, what would be the tension? So here we can see that we know that the tension force acts away from the point of observation. So if we consider this point or the object as the point of observation, since we are considering the object as the point of observation, so the force would be acting away from the point of observation. That means the tension would be acting away from the point of observation. So if we consider this object as the point of observation, then the tension force would be acting away from the point of observation, that is away from the object. So this is our tension, and if we break the force into its component, then it would be T sine 30, that is the opposite, and T cos 30, that is adjacent. And x, if we break the x into its component, then what would be this angle? So to find this value of angle, so first of all, we know that this angle is 90 degree and this total angle is 180 degree. So also we know that this angle is 30, this angle is 90. What would be this angle? So 180 minus 30 minus 90, that is 60 degree. Since this angle is 60 degree and this angle is 90 degree, so what would be this angle? So 180 minus 90 minus 60, that is this angle will also be 30 degree. So this angle is 30 degree. That means x, so this side would be x cos 30 and this side would be x sin 30. So we break the forces into its component, and you have to remember that since this is an object and it has some mass, so obviously it has a weight that is acting vertically downwards. So since it is an object and it has some mass, so the weight is acting vertically downward, that is mass into gravitational field strength, where G is the gravitational field strength, that is G has a value of 10 according to the given information that G is 10 meter per second square. So we break the forces into its component, and since the system is in equilibrium, so at equilibrium we know that the resultant force is 0. That means the force at the left is equal to the force at the right, and the force at the up is equal to the force at the bottom. So up is equal to bottom, that means the resultant force in the upward direction is 0. Then left is equal to right, that means the resultant on the left and the right is 0. That means the object is at equilibrium. So we equate the forces on the up and the forces on the down. So the upward force is T cos 30, that is T cos 30, and x sin 30, and the downward force is 0.2 g. So 0.2 g, and there are no up and down forces outside of these three forces. So we equate up is equal to down, then left is equal to right, that means the force on the left is equal to the force on the right. So x cos 30 is equal to T sin 30. So we equate this and we express x in terms of t. So after solving, we express x in terms of t. Then we substitute the value of x in this equation to find the value of t, that is 1.732 Newton, that is approximately 1.73 Newton. Then after substituting the value of t in this equation, we get the value of x as 1 Newton. So this is the answer. Number 3. A car travels along a straight road with a constant acceleration a, where a is greater than 0. So the car travels with an acceleration of a. The car passes through points A, B and C in that order. So the car passes through point A, point B and point C. The speed of the car at A is u meter per second in the direction AB. So in the direction AB, the speed is u meter per second. And in the direction AB, that means in this direction. So in the direction AB means that in this direction, the speed is u meter per second. The distance BC is twice the distance AB. So the distance BC, that means the distance BC is twice the distance AB. So again, the distance BC is twice the distance AB. The car takes 8 seconds to travel from A to B and 10 seconds to travel from B to C. So 8 seconds from A to B and then 10 seconds from B to C. Find u in terms of A. So we need to express u in terms of constant acceleration A. So we know the three equation, that is S is equal to ut plus half at square, v square minus u square is equal to 2s, and v is equal to u plus at. So we have given the value of distance and we need to find u. A, we know the value of A, so we can use this expression, that is S is equal to ut plus half at square, where is AB. For distance AB, S is equal to ut plus half at square. So we have given the value of u as ut, and the time is 8 seconds from A to B. So from A to B the time is 8 seconds plus half A. So we have given A as the acceleration t square. So t square. So distance AB is this value, and for distance BC. So for distance BC, if we consider by the equation S is equal to ut plus half at square, then u is the initial speed at B. So by using this expression S is equal to ut plus half at square, so u is the speed at B, but we don't know the speed at B right now. So we don't know the speed of B right now. That's why we consider the distance AC. If we consider the distance AC, then we know the initial speed u. So if we consider the distance AC, then we know the value of initial speed u. But if we consider the distance BC, then we don't know the value of speed at B. Therefore, we consider the distance AC. So AC is equal to ut plus half at square. So the velocity is u. So u and t. So the total time, since we are considering AC, so the total time is 8 plus 10, that is 18. So ut plus half at square. And since acceleration is constant acceleration, so the acceleration would be same. So the distance AB and BC, AC. Now we know that if we consider the distance AB as x, so if we consider the distance AB as x, then the distance BC would be twice the x. So distance BC would be twice the x, and if AB as x and BC as twice x, then AC would be 3x. So distance AC would be 3x. So the distance AC is equal to 3x. That means the distance AC is equal to 3x. So 3x, and we know the value of x, that is, what is the value of x? That is, if we consider the distance AB as x, that means if we consider this value as x, then BC is equal to 2x. So AC is equal to 3x. So it's equal to 3x. That means since AC is equal to 3x, so AC is equal to 3x. So we substitute the value of x, that is the distance AB, in this equation to express u in terms of A. So we express u in terms of A. That is, u is equal to 11A. Now for part B, find the speed of the car at C in terms of A. So we need to find the speed of the car at C in terms of A. So in terms of A. So speed of the car at C. So what would be the speed? So we need to find the value of speed at car at C, and we know the value of total time, and we know the value of u, who has expressed u in terms of A, that is u is equal to 11A. u is equal to 11A. So v is equal to u plus at, and we know the value of u. The value of u is 11A, and we need to find the value of car at C in terms of A. So we need to find the speed in terms of A. Since we need to find the speed in terms of A, so v is equal to ut, v is equal to u plus at. So v is equal to u plus at, where we know the value of u, and since we need to find the answer in terms of A, so u plus A, and what is the total time? So v is equal to u plus at. So the total time is 8 second plus 10 second, that is 18 second. So v is equal to u plus at, that is 29A. So v in terms of A, that is 29A. Number 4. A particle travels in a straight line. The velocity of the particle at time t seconds after leaving a point O is v meter per second, where we have given this expression, that is the speed in terms of k and t. The distance traveled by the particle in the first 2 seconds of its motion is 6 meter. So for the first 2 seconds, we have given the value of distance as 2 meter, that is s as 2 meter, and we have given the time. You may assume that v is greater than 0 in the first 2 seconds of the motion. Find the value of k. So we need to find the value of k, and we know the value of distance and the value of time. So we have given the expression in terms of velocity, and we have given the information in terms of distance. So we can integrate velocity. If we integrate velocity, then we would get the displacement. So while integrating velocity, that is s is equal to integrating the velocity in terms of dt, that is k, so t cube, that is power plus 1 by the power minus 4t square by 2 plus 3t plus c. So while integrating, we get an extra constant c. So after integrating, we get an extra constant c, and if we consider, that means at point O, since at time t is equal to 0, the displacement is also 0. So at point O, if we consider the time t is equal to 0, then the displacement is 0. So if we substitute the value, then the value of c is also 0. So we get the displacement equation in this format, where c is 0. And we express the displacement expression in terms of t, and we know the value of displacement of the distance, that is 6 meter. So we know the displacement of the distance, that is 6 meter, and the time is 2 seconds. So after substituting the value, we find the value of k as 3. So the value of k is 3, that is the value of k. Then for part B, find the value of the minimum velocity of the particle. You do not need to show that this velocity is minimum. So we know that for maximum or minimum velocity, dv by dt is equal to 0. So for maximum or minimum velocity, we know that dv by dt is equal to 0. So for maximum or minimum value, dv by dt or dx by dt is equal to 0. So for maximum or minimum value, dv by dt is equal to 0. And we know the expression for v, that is the expression for v. So what is the dv by dt? So v is equal to this expression, where we need to substitute the value of k, that is 3. So there is, okay, so we have to substitute the value of k by 3. So substituting the value of k by 3, we get the value of v in terms of t. Now dv by dt is equal to 3t square. So 2 into 3, that is 6t. So t square minus 1, that is 6t, minus 4 is equal to 0. Because at maximum or minimum value, dv by dt is equal to 0. So we equate this to 0 and find the value of t. Now after substituting the value of t in the equation of velocity, we find the velocity as 5 by 3 meter per second. Number 5. A van of mass 4500 kg is towing a trailer of mass 750 kg down a straight hill inclined at an angle of theta to the horizontal, where we have given the value of sine theta. So we have given the value of sine theta, and we have given the mass of the van and the mass of the trailer, and the mass and the trailer are connected by a string. So we have given the mass of the van, that is 4500 kg. So since we have given the value of mass, so we know that weight is equal to mass into gravitational field strength. So the weight is acting vertically downward. So mass into gravitational field strength, where we consider the gravitational field strength as g. So 4500 g and 750 g. That is the mass of the van and the trailer. And the van and the trailer are connected by a light rigid tow bar. So they are connected by a light rigid tow bar. And since we know that the tension force is acting away from the point of observation, so if we consider this object as the point of observation, then the tension force is acting away from the point of observation. And if we consider this object as the point of observation, then the tension force is acting away from the point of observation. Now, the van and the trailer are connected by a light rigid tow bar which is parallel to the road. So the tow bar is parallel to this inclined plane. There are constant resistance forces of 2500 Newton on the van and 300 Newton on the trailer. So first of all, we have given that the van and the trailer are moving down the straight road. So they are moving down the straight road. Since the van and the trailer are moving down the straight road, so they are moving down the straight road. That means the resistive force is acting upward. Since the object is moving downward, so to oppose the movement, the resistive force must act upward. So the resistive force of 2500 Newton for the van, that is at this much Newton on the van, that is 2500 Newton on the van, and 300 Newton on the trailer is acting upward. Since the system is moving downward, so the resistive force is acting upward to oppose the movement. Then it is given that the tension in the tow bar is 450 Newton. So we have given this value of tension and this value of tension as 450 Newton. And we have given the resistive forces. Now find the acceleration of the trailer and the driving force on the van's engine. So acceleration and the driving force, we consider this as dF of the van's engine. So driving force of the van's engine is dF, that is acting up, that is acting forward. Since it is a driving force, so it is acting forward, and we need to find the acceleration. So if we break the mass into its component, then 4500g, so 4500g sine theta, that is opposite, so sine, and since adjacent, so cos theta, 4500g cos theta. Then again 750g, so 750g sine theta, that is the opposite, and 750g cos theta, that is the adjacent. Then so driving force, that is the forward force, plus this is also acting in the forward direction, that is in this direction, so plus 4500g sine theta minus the resistive force that is acting in the backward direction, and also the tension force is acting in the backward direction, is equal to mass into acceleration. So mass is 4500g and acceleration, this is for the van. And for the trailer, the forward force is a tension force, so tension force is acting in the forward direction. Then this force, that is 750g sine theta, is also acting in the forward direction, minus the resistive force, that is 300, is equal to mass into acceleration, that is the mass of the trailer and its acceleration. So since they are connected object, so the acceleration would be same for both the object. So we have given this expression and this expression. Now for the trailer, we know the value of tension, so we have given the value of tension, that is the tension in the tow bar is 750 Newton. So we know the value of tension, that is 450 Newton, sorry, this is 450 Newton, and 450 plus 750, G is 10, G for mechanics is 10 meter per second square, and for physics it is 9.81 meter per second square. So 450 plus 750 G sine theta minus 300 is equal to mass into acceleration. So after calculating, we get the acceleration is 0.7 meter per second square. So after substituting the value of acceleration in this equation, that is substituting the value of acceleration, we get the driving force as 3850 Newton. So we find the value of acceleration and the driving force as these values. So here the mass is 4500 and the acceleration is a. So mass into acceleration. Similarly, the mass here is 750 and the acceleration is a. So the mass into acceleration, mass into acceleration. Now for part B. On another occasion, the van and the trailer ascend a straight hill, inclined at an angle of alpha to the horizontal, where we have given the value of sine alpha as 0.09. So we have given the value of sine alpha, and by using this value, we find the value of cos alpha. Now, the van and the trailer ascend the straight hill. That means they are moving up the straight hill. So this angle is alpha, and the system is moving upward. Where we have given the value of sine alpha, the driving force of the van's engine is now 9100 Newton. So the driving force of the van's engine, so this is the van that is moving upward, and this is the trailer that is also moving upward, that is connected to the van. So the driving force of the van is 9100 Newton, and the speed of the van at the bottom of the hill is 20 meter per second. That means at the bottom of the hill, the speed is 20 meter per second for the van. The resistance to the motion is unchanged. So the resistance to the motion is unchanged. That means what are the resistive forces? So the resistive force is 2500 Newton for the van and 300 Newton for the trailer. So 2500 Newton for the van and 300 Newton for the trailer, and since the system is moving upward, the resistive force is acting downward. Now the resistive force is unchanged. Find the acceleration of the van and the tension in the tow bar. So what would be the tension? Since tension force acts away from the point of observation, so if you consider this object as the point of observation, the tension force is acting away from this point of observation, and if you consider the van as the point of observation, the tension force is acting away from this point of observation. So we break the forces in this component, and the weight is acting vertically downward, so the weight of the van is 4500 g. So 4500 is the mass and g is acting vertically downward. So the weight is acting vertically downward. So 4500 g. So if you break the weight into its component, then 4500 g, since the angle is alpha, so it will be cos alpha. 4500 g cos alpha and 4500 g sin alpha. So here I have written all the alpha in terms of theta. So consider the alpha as theta. So 4500g sin theta for the opposite and 4500g cos theta for the adjacent. Similarly, 4500g sin theta for the opposite, 750g sin theta for the opposite and 750g cos theta for the adjacent, where we consider the alpha as the value of theta. So we have written all the answers in terms of theta. So okay, alpha is equal to theta. Now we need to find the acceleration of the van and the tension in the tow bar. So what would be the acceleration and the tension? So for the van, driving force is acting upward. So driving force, so the forward force would be the force which is acting in the direction of movement. So the driving force is acting in the direction of movement. So driving force is the forward force minus tension minus this resistive force and the downward component of weight, that is 4500g sin theta. So this is also acting in the negative direction or in the backward direction. So minus this value is equal to mass into acceleration. Similarly for the trailer, the tension force is the upward force and the backward force is the 300 Newton. So 300 Newton and 750 g sin theta is equal to mass into acceleration. So we get two equations, that is this is the second equation, and after solving, this is the first equation. Then if we equate both the equation, since tension is the same, so if we equate, we get the value of acceleration as 0.3 meter per second square. So we get the value of acceleration. Now after substituting the value of acceleration in any of this equation, we find the value of tension as 1200 Newton. Then find the speed of the van when it has traveled a distance of 375 meter up the hill. So the distance traveled is 375 meter. So we know the value of s and we know the value of acceleration. So by using the equation v square minus u square is equal to 2s. So we need to find the speed of the van. That is the v. So v square is equal to 2. Acceleration is 0.3 and the distance is 375. And what is the initial speed? So you must remember that we have given the initial speed of the van is 20 meter per second, that we have given at the bottom of the hill. So we know the value of u. After substituting this value, we find the value of v, that is 25 meter per second. A cyclist is traveling along a straight horizontal road. The total mass of the cyclist and her bicycle is 80 kg. So the mass is 80 kg, and if you write the weight, then weight is equal to mass into gravitational field strength, where gravitational field strength is g. So 80 g. Then there is acting vertically downwards. There is a constant resistance force of magnitude 32 Newton to the cyclist motion. So the resistance force is 32 Newton at an instant when she is traveling at 7 meter per second. So when the speed is 7 meter per second, we have given the value of acceleration. Find the power output of the cyclist. So we need to find the power output. So we have given the value of speed and the acceleration, and we need to find the power. So we know that driving force minus resistive force is equal to mass into acceleration. So driving force we consider as df minus the resistive force. So the resistive force is 32 Newton, that is the resistive force, is equal to mass is 80 and the acceleration we have given is 0.1. So we find the value of driving force. Now since we know the value of driving force, now we know that power is equal to force into velocity, that is power is equal to driving force into velocity. So we know the value of driving force and the velocity is 7 meter per second. So after multiplying, we get a power that is 280 watt. Find the steady speed that the cyclist can maintain if her power output and the resistive force are both unchanged. So power and the resistive force are unchanged. So resistive force is unchanged. That means we know the resistive force is 32 Newton. So the resistive force is 32 Newton and the power as 280 watt. So power as 280 watt, they are unchanged. But since the cyclist is moving at a steady speed, so we know that at steady speed, resultant force is equal to 0 if net is equal to 0. That means the forward force is equal to the backward force. since forward force is equal to the backward force, that means the resultant force is 0. So we have given the value of resistive force, so that is the backward force. So backward force must equal to the forward force, that is the driving force is also 32 Newton. Since the resultant force is 0, so forward is equal to backward, that is the forward force comes to be 32 Newton. So we know the driving force and the value of power. Since we know these two values, and we need to find the steady speed, that is the value of v. So power is equal to force into velocity, and the velocity is equal to power by force. So power by force, that is 32. We get the velocity as 8.75 meter per second. The cyclist later descends a straight hill of length 32.2 meter. So the hill is straight hill, and the cyclist descends the hill. That means the cyclist is moving downwards the hill, inclined at an angle of sine inverse of 1 by 20. So the value of theta is given, that is the angle is given as sine inverse of 1 by 20 to the horizontal. Her power output is now 120 watt. So we have given the value of power, the resistance force, and the resistance force now has variable magnitude such that the work done against this force in descending the hill is 1128 joules. So work done against resistance, or the work done against friction, is 1128 joules. The time taken to descend the hill is 4 seconds. So the value of time is 4 seconds. Given that the speed of a cyclist at the top of the hill is 7.5 meter per second, so the speed at the top of the hill is 7.5 meter per second. That means v is 75 meter per second. Find the speed of the cyclist at the bottom of the hill. So v bottom, so we need to find the speed at the bottom. So if we consider the two scenarios, that is before and after. So before we must have kinetic energy, gravitational potential energy, and work done by driving force. And after we have kinetic energy, work done against frictional force, or work done against resistance, and the gravitational force. So you must have to remember these three things. That is for driving force, for before and after. So for before, we have kinetic energy, gravitational potential energy, and work done by driving force. And after we have kinetic energy, then gravitational potential energy, and work done against friction, or work done against resistance. Now considering before, so kinetic energy before, that means kinetic energy at the top, so half. So we have given the mass. So what is the mass of the cyclist? So the cyclist mass, now the mass of the cyclist is 80 kg. So half mv square, that is the kinetic energy is equal to half mass into speed square. And what is the speed at the top? That means the speed before. So speed at the top, or the speed before, so the speed of the cyclist at the top is 7.5. So half mv square, that is the kinetic energy before. Then what is the gravitational potential energy? It is mass into gravitational field into height. So mass is 80, gravitational field strength is 10 meter per second square, that is given. And what is the value of height? So we have given the value of angle, so we have given the value of theta. Now we have given this length. So what is the height? That is the vertical height. So for gravitational potential energy, we must have to consider the vertical height. So sine theta is equal to opposite by hypotenuse. So opposite by hypotenuse, so we need to find the opposite, that is the height. So h is equal to sine theta, that is we substitute the value of theta and the value of hypotenuse to find the value of height as 1.61 meter. So the height is 1.61 meter. So we get the gravitational potential energy. And what is the driving force? Work done by driving force. So work done by driving force, that is, we know that work done is equal to power into time. This power is equal to work done per unit time, or energy per unit time. So power is equal to work done per unit time, or energy per unit time. So work done would be power into time. So work done is equal to power into time. So we have given the value of power as 120, and the time, so time is 4 seconds. So power into time, that is 480 joules. So this is for the before, that means at the top. So at the top or the before. So top or before, and after or bottom. So at the bottom, since the cyclist is moving towards the bottom, so at the bottom point, or at the ground level, the gravitational potential energy is 0, because the height is 0. because the vertical height is 0, so the gravitational potential energy is 0. And what is the kinetic energy? So kinetic energy is equal to half mv square, where we need to find the speed at the bottom. So we need to find the speed at the bottom. There is speed at the bottom. So half mv square. So we write this expression in terms of v. That is the speed of the bottom. And we have given that the work done against resistance or work done against friction is 1128 joules. So after substituting these values, then if we equate before is equal to after, that means the value, this value is equal to these values. So after equating, we get the velocity. There is v square is equal to 72.25. So v is equal to root over 72.25, and you need to remember that you have to place a plus minus. So plus minus 72.25, that is v comes to be 8.5 meter per second and negative 8.5 meter per second. So negative 8.5 is not the answer, or it is inadmissible or not acceptable. So negative 8.5 is not the answer or inadmissible, and our answer is 8.5 meter per second. So the speed at the bottom is 8.5 meter per second. For this question, I have drawn the exactly same diagram at the bottom, that is this diagram. So the diagram shows the track ABCD, which lies in a vertical plane. So the track A, B, C and D in the vertical plane. The section AB is a straight line inclined at an angle of 30 degrees to the horizontal and is smooth. So the section AB is a straight line and is inclined at an angle of 30 degrees to the horizontal. Then the section BC is a horizontal straight line and is rough. So we have given that the section AB is smooth and BC is rough. So the section BC is rough. That means there is an effect of friction, that is mu r. The section CD is a straight line inclined at an angle of 30 degrees to the horizontal and is rough. So the section CD is inclined at an angle of 30 degrees to the horizontal. So this angle is also 30, this angle is also 30, and there is an effect of friction, that is mu r. The length of AB, BC and CD are each 2 meter. So the length of AB, BC and CD are same, that is 2 meter. And AB is a smooth plane, that is smooth. BC and CD are rough planes. A particle is released from rest at A. So since the particle is released from rest, that means initially it has a speed of 0 from A. The coefficient of friction between the particle and both BC and CD is mu. That means the coefficient of friction is mu. There is no change in the speed of the particle when it passes through either of the point B or C. So either of the point B or C, it has no change in speed. That means when it passes through B, suppose it has a speed of V, so its speed remains V, and when it passes from this point to this point at C, the speed, suppose it is 2, so it remains 2. That means there is no such change in speed between this plane and this plane for B, and this plane for C. That means there is no change in speed of the particle when it passes through either of the point B or C. It is given that mu is 0.1. So we have given the value of mu. Find the distance which the particle has moved up the section CD when it has a speed of 1 meter per second. So we need to find the distance when the particle has moved up the section CD. So up the section CD when it has a speed of 1 meter per second. So when it moves up the section CD, suppose at a distance it has a speed of 1 meter per second. Suppose at this distance it has a speed of 1 meter per second. Now we need to find this distance. So to find this value of distance, first of all, for the section AB, if we just consider, then we don't have given the mass of the object, so we consider the mass as m. So the mass as m. So for the object, the weight is acting vertically downward, that is the mg is acting vertically downward, and this is the, if we break the weight into its component, then it would be mg cos theta. So mg cos 30, so this side is cos and this side is sine, so the opposite is sine and the adjacent is cos. So the force that is parallel to the plane, that is mg sine theta, that is parallel to the plane, is equal to mass into acceleration, and since the section AB is smooth, that means there is no effect of friction. So mg sine 30 is equal to mass into acceleration, so mm. So since m is same, so we can cancel this, and acceleration comes to be 5 meter per second square. So the acceleration is 5 meter per second square. And what is the velocity of the particle at point B? So the velocity, we consider this as v. So v square minus u square is equal to 2as. So vb square minus, since at a it is at rest, so the speed is 0. That means the value of u is 0 is equal to 2, and the acceleration is 5, and the distance AB, BC and CD is 2 meter. So we have given the value of distance as 2 meter. So the speed at B, that is VB, is equal to root over 20 meter per second. So the speed at B is root over 20 meter per second. So we know the speed at this point. So we know the speed at B. Now to find the speed at C, so to find the speed at C, that is VC, so VC square minus VB square is equal to 2AS. So what is the value of acceleration? Now at this plane BC, we know that there is an effect of friction, that is mu r. Since the friction is acting, so the acceleration value must change. So if we consider the object is at this point, so for this point, so there is no forward forces acting. Now the weight is acting vertically downward, and there is no forward force acting. But we know that there is frictional force, that is mu r. So the forward force is 0. So forward force is 0 and minus mu r. So mu r, and we have given the value of mu as 0.1. So 0.1 r. And what is r? R is equal to, so weight, that is mg, is acting downward. So r is equal to this force. That is the normal reaction force. That means r is equal to mg. So r is equal to mg. So mg is equal to mass into acceleration. So mass into acceleration. So here m and m cancels, and g, we know that the g is 10 meter per second square. So after substituting the values, we get the acceleration as minus 1 meter per second square. So we know the acceleration. So 2a, and the distance is from B to C, the distance is 2 meter. So 2a is plus u square. That is the speed at B. So we know the speed at B. So after substituting these values, we find the speed at C, that is vc square is equal to 16. Vc is equal to plus minus 16. That is Vc is equal to 4 or minus 4. So minus 4 is not the answer, or it is inadmissible. And our answer is 4 meter per second. So for point C, the speed is 4 meter per second. So for point C, the speed is 4 meter per second. That is Vc is equal to 4 meter per second. So we know the speed at this point, and find the distance when the particle has moved up the section CD when it has speed 1 meter per second. That means when it moves up the section CD, it has a speed of 1 meter per second. That means at the topmost point, it has a speed of 1 meter per second, and at point C, that means at the bottom point, it has a speed of 4 meter per second. And we need to find the distance, that is the distance. So we can use the formula v square minus u square is equal to 2as. Now to find the value of speed from this equation, we need to first find the acceleration. So what is the value of acceleration? So to find the value of acceleration, so let's consider the object is at this point. So the weight is acting vertically downward, that is mg, and this side would be mg cos theta and mg sin theta, where the value of theta is 30 degree, and the frictional force is mu r. So mu r, so is at, this is backward force, and the object is moving upward. Since the object is moving upward, so the frictional force is acting backward. So negative frictional force, and the downward component of weight, since the force that is parallel to the plane, there is a frictional force and the weight is acting downward while the object is moving upward, and since the downward component of weight is downward, so that means it is negative. So negative mg sin 30. So mg sin 30 is equal to mass into acceleration, where we can cancel the value of mass. After cancelling the mass and substituting the value of mu, that is given, that is 0.1. R is the normal reaction force. So since R is the normal reaction force, so this component of weight is acting downward, so the R is acting vertically upward. So what is this component of weight? So this component of weight, that is perpendicular to the plane, is mg cos theta, where we know the value of theta is 30 degree. So R is equal to this value, so we substitute the value of R and find the acceleration as negative 5.866 meter per second square. So we know the value of acceleration. Now using the equation v square minus u square is equal to 2as. So we know the final speed as 1 meter per second, initial speed as 4 meter per second is equal to 2as. So after substituting the values, we find the distance as 1.28 meter. So we have solved the part A, that is, this is the part A. Now for part B. So for part B, we have drawn the exact same diagram that is given in the question, that is this diagram. Then after drawing the diagram, it is given instead that with a different value of mu, the particle travels 1 meter up the track from C before it comes instantaneously to rest. So for a different value of mu. So the value of mu is not the same that is given here. That is, it is not now 0.1. So the value of mu has changed. So the value of mu has changed. And for this changing value of mu, the particle travels 1 meter up the track from C. So from point C, the particle travels 1 meter up the track. So since it travels 1 meter up the track, so this distance is 1 meter. So we consider the distance as Cx. So distance Cx as 1 meter. So it travels 1 meter up the track before it comes instantaneously to rest. That means after traveling this 1 meter, it comes to rest. That is, the velocity at this point is 0. Find the value of mu. So we need to find this different value of mu and the speed of the particle at the instant when it passes C for the second time. So what does this mean? So we need to find the value of mu and the speed of the particle at the instant when the particle passes C for the second time. That means after the passing through this point, it comes instantaneously to rest. And after coming instantaneously to rest, it again moves downward to C, to this point. And we need to find the speed of the particle when it is again at point C. So we need to find the speed of the particle when it is again at C. So first of all, again, if we consider the section AB, so mg sine theta, that is the downward component of weight that is parallel to the plane. So the component of weight parallel to the plane is equal to mass into acceleration. And since the section AB is smooth, so AB is smooth, BC is rough, and CD is rough. That is given. So that is already given here that AB is smooth, BC is rough, and CD is also rough. Now, since AB is smooth, that means the only force is acting the downward component of weight that is parallel to the plane. So mg sine 30 is equal to mass into acceleration. So acceleration is 5 meter per second square. Now using acceleration, what is the speed at this point? So v square minus u square is equal to 2as. So initially at this point it is at rest. So u is equal to 0 and 2as. So vb, that means the speed at this point is root over 20. So we know this value till now. Now we know the speed of b at this point. Now suppose the object is at this point. So for this point, the weight is acting vertically downward, mg, and the normal component of the vertical component, that is the normal force, is r. So normal reaction force is r. Now this force is acting vertically upward, and the mu r, since the object is moving in this direction, after passing through this point it is moving in this direction. So the mu r is acting in this direction, that is towards the left. So there is no forward force. So there is no driving force minus the backward force, that is mu r. So mu r is the backward force. Now why the object has no forward force? Because the object started at this point, and after passing this through point, suppose the object is at this point. So if we consider this point, then we can see that there are no other driving forces that are acting on the object. The object has passes through this point, but now at this point there are no driving force acting. The only force is acting is the resistive force, and no driving force is acting. Therefore, for this point, there is no driving force is acting. So no driving force minus mu r is equal to mass into acceleration. So minus mu, and the value of r is, since it is mg, so r is equal to mg. So minus mu r is equal to mass into acceleration. So mass into acceleration, so we cancel the mass, and acceleration is equal to negative mg, negative mu g. So acceleration is equal to negative mu g. So this is for the acceleration. Now what is the speed of the particle at c? So the speed of the particle at c, that is vc. So we know the speed of the particle at b, that is vb, and we know the acceleration that we have found. Now what is the speed of the particle at c in terms of mu, since we don't know the value of mu? So v square minus u square is equal to 2s, where v is the speed of the particle at c, square minus u square is equal to 2, acceleration is negative 10 mu, and s. So the distance AB, BC and CD, we have given that it is 2 meter. So substituting the value of 2, we find Vc square is equal to this value. That means the speed of the particle at C is this value. So we know the speed of the particle at point C, speed of the particle at C in terms of mu. Since we need to find the value of mu, so considering the mu, we find the speed of the particle at C. So we know the speed at C, and we know that this distance is 1 meter. So this track is 1 meter, and the speed at this point, since it comes to instantaneous rest, so the speed at point is 0. So again, by using v square minus u square, so first of all, okay, so we find the vc square, that means the speed of the particle at c. So we have found the speed of the particle at c. Now what is the acceleration in this plane? So first of all, for the acceleration in this plane, that is in this plane, so the weight is acting vertically downward, that is mg, and this side would be mg cos 30, that is the angle is 30, and this side would be mg sin 30. So for this object, the mg sin 30 is acting backward, and since the object is moving upward, so mu r is acting backward, that is mu r, and here this component of force is r. So r is equal to mg cos 30. So mu r minus mg, and there are no forward force. So minus mu r minus mg is equal to mass into acceleration, where there is no forward force. So minus mu, and the value of r is mg cos 30. So r is mg cos 30. There is a vertical component of weight. So mg cos 30 minus mg sin 30. So minus mg sin 30, that is the downward force. So negative mu r minus mg sin 30 is equal to mass into acceleration. So we find the acceleration in terms of mu. Now we find the speed c square in terms of mu and the acceleration in terms of mu. So speed c square and acceleration in terms of mu. Now we have found these values. Know the speed c square in terms of mu and the acceleration in terms of mu. So the acceleration in terms of mu, that is negative 8.66 minus 5, and the u square in terms of mu, that is 20 minus 40 mu. So speed c square in terms of mu. Now for the distance cx, so distance cx, we have given the distance the particle travels until it comes to rest is 1 meter, so 1 meter, and the speed at this point when it comes to instantaneous rest is 0, and u square, we have given the value of u square, that is the initial speed square. So v square minus u square is equal to 2s. So final speed square is 0 minus u square. So we have given the value of u square, that is 20 minus 40 mu is equal to 2, and the acceleration, so we have substituted the value of acceleration in this equation, and the distance is 1 meter until it comes to rest. So after substituting these values, we can easily find the value of mu, that is 0.17445, that is approximately 0.175, that is the value of mu, and it has no unit. Now we find the value of mu, that is the second value of the defined value of mu. Now again at point C. So again at point C, we need to find the speed. That means the speed of the particle at the instant when it passes C for the second time. That means when it passes C for the second time, what is the speed of the particle? So to find the speed of the particle, so first of all, for the object, for this object, now the particle after moving from X downward, so the particle comes to rest at point X, then again the particle is moving downward, and we need to find the speed at C again when it moves downward. Since for now the object after coming to rest at X is moving downward, so it moves upward, then again it moves downward. So now the particle after moving upward, it is moving downward. Since the particle is moving downward, so mu r is acting upward. Since the particle is moving downward, so mu r is acting upward. So mu r is acting upward. So the object is moving downward. So the downward component of weight is, that is parallel to the plane, is mg sin 30, and now this force is acting in the direction of the movement. This force is acting in the direction of the movement, that is this direction of the movement, Therefore, this force is positive. And mu r is the resistive force, therefore it is negative. So minus mu r is equal to mass into acceleration. And after substituting our values, that is the g sin theta minus mu r is equal to mass into acceleration. And if you cancel the value of masses, so the acceleration comes to be this value. That is 3.489 meter per second square. So we know the value of acceleration. So we know the value of acceleration. Now the acceleration is for the object when it is moving downward. So the acceleration is for the object when it is moving downward. So we know the value of acceleration. Now the speed again at c. So that is vc square is minus u square is equal to 2s. And what is the u? U is the speed at this point when it is instantaneously at rest. So u is 0. So 0. That is u is 0. So vc square is equal to 2as. So the distance cx, we know that this distance is 1 meter. So after substituting our values, and we get the value of vc as this value, that is plus minus 2.641. That is vc is equal to 2.64 meter per second, or negative 2.64 meter per second, negative 0.64 meter per second. Sorry, this is negative 2.64 meter per second, negative 2.64 meter per second. So negative 2.64 is inadmissible or not the answer, and our final answer is 2.64 meter per second. So our answer is 2.64 meter per second. That is our final answer. That is the speed of the particle when it is again at c.